All right, this is the second half of the opening day lecture. It stopped with the binary conversions, and now we're going to talk a little bit about software. Software is what this class is about. I went over hardware, and you all are responsible for knowing about the hardware, but this is what we're going to be dealing with. Software is comprised of instructions that get a computer to perform a task. Right? There's two main kinds of software, and you definitely need to know the difference. There's application software, which is just things like word processors, databases, spreadsheets, painting programs, web browsers, emails. Those are application software, right? Each one performs a certain task. The other kind of software is system software. That's like operating systems, right? System softwares are things like Windows, the Macintosh OS, Unix, and Linux or Linux, depending on how you want to say it. Right? A program is a set of instructions a computer follows in order to perform a task. Seems simple, but that is the crux of programming, and it is something that's likely to come up and pop up and get you all on a test or a quiz. Right? Collectively, these instructions are called algorithms. They're well-defined steps to complete a task. Okay, algorithms, we don't really start dealing with them till the end of this class. I would say November or so. And the second part of this class, CIS 115, deals almost exclusively with algorithms. Up until November, we're just going to be dealing with how-tos, how to do this, how to do that, the basics of programming. Then we start dealing with algorithms. These are the instructions that make up these programs. Okay, what are programming languages? Okay, we're talking about languages now. Programming languages allow programmers to code software. Okay, we got three major families, all right, or levels of languages. All right, we got machine language, assembler language, and let me move this box down here, and high-level languages. All right, we will only be programming at high-level languages. But it's important that you know what machine languages and assembler languages are. All right, machine languages. All right, we just finished the bits, all right, the ones and the zeros. This is the native language of a computer. This is a machine language. Machine languages are at the very, what's the word I'm looking for here? But they're at the very bottom level, right? The most native, the most, I can't think of the word I'm looking for here, but you just deal with ones and zeros, right? That's machine languages. They take these machine languages and actually run programs, just ones and zeros, bits and bytes, kilobytes. That's machine languages, right? This is really hard to program in because one misplaced one or zero will cause the program to totally fail. So every bit and byte has to be in order. And like I said, this is almost impossible for somebody to code in. All right. The next level up is assembly languages. All right. Assembly languages actually have steps to make things easier programming. Right? Assembly languages are comprised of a set of elements, of elemental commands, really tiny, simple little commands, which are tied to specific processor. All right. Assembly language code needs to be translated to a machine language before the computer processes it. And I'll have a schematic here in a minute, some pictures to show you. Right now, you need to know that assembly languages, here's what the programs look like. Add R2, that means like add register 2. Move R3, which is move register 3. That's what these programs look like. Somebody not super familiar with assembly languages, this just looks like gibberish. It's like little three letter acronyms and an R2 or just a simple little place in memory. All right, here's what it looks like. The assembler language, right here's the machine code on the far right. That's what you saw the other day when we were working with bits and bytes, right? Right? That's the machine code. The assembler language and the actual assembler, which is in our IDE, actually works like this. You've got move register 1, number 15. You've got all these little codes that tells the assembler how to deal with the machine code. So at the very bottom level, and this is your big takeaway out of this, is machine code, all right? And the assembler works with an assembly language to actually make the code work. All right. Now we're dealing with what we're doing here in C++, high-level languages. Okay, high-level languages represent a giant leap towards easier programming. It's more of a natural language similar to English. All right. Okay, we divide the higher level languages into two groups: procedural languages and object-oriented languages. Okay, that's got a high probability right there for a quiz or a test question. We divide the high-level languages into two groups: procedural languages and object-oriented languages. All right, an example of what this kind of code looks like is just what you see here. If x is greater than a counter, then counter equals counter plus 1. Right? So you can actually kind of get an idea like that. Counter plus 1 means you've incremented counter and assigned it to counter. So, I mean, now we're getting to a language where it makes a little bit of sense. I mean, not like you could intuitively go in and do it, but it's better than machine code or assembler language. All right, here is the whole gamut of what we're talking about. All right, high-level languages is codes that you can actually read and actually probably through inductive reasoning kind of figure out. Right, it compiles. Right, then you've got the assembler language. All right, as the next level down, it's fairly complicated. Then the assembly language works with the assembler on the machine code. So I guess the big takeaway from here is the compiler compiles the high-level language, the assembler assembles the assembly language, and all of that at the very bottom level, the most rudimentary, that was the word I was looking for earlier that I couldn't come up with, is the machine language on the far right. So you can see the progression across here. High level compiles the assembly language, the assembler, machine language. So that'd be good for the test to kind of review this. But like this little purple arrow shows, this is where we're going to be doing our coding. Okay, like I said before, there's two kinds of higher level languages: procedural language and object-oriented languages. Procedural languages were the old-timey languages, and you've heard of some of these before. C, which started the whole C family, which from that comes C++, Java, C#, all of those. COBOL, which was really big when I was your age. Fortran was big when I was your age. Lisp, Perl, HTML, VB script, all of these are procedural, which means it's just step after step after step after step after step, right? If one step doesn't work, probably the whole program isn't going to work. All right, this was a big step for computer programming to do these procedural languages, which probably was from like 1960 to mid 1980s. I may be wrong on those dates, but that's not anything I'll test you on. I'm just trying to give you a bearing of where we're at in the history of programming. Object-oriented languages. This is when programming really got good. This started, like I said, mid 80s. All right. The big takeaway from this is that object-oriented languages has reusable code. It's encapsulated, all right? Um, and like it says here, modeling data, it's encapsulated. You can reuse code, and code can call with on code, right? This third thing, programmers code using blueprints of data models called classes, all right? That's a big thing that we're going to be getting to in 115. Don't have to worry about it now. But examples of object-oriented programming include C++, Visual Basic, Java. All right, what is a program made up of? Language elements, all right? Reserved words, okay? Reserved words have special meaning. Um, they can only be used for the intended purpose. You can't name something double, all right? Um, double is a reserved word, all right? Namespace is a reserved word, okay? Usually when you type in a reserved word, it'll turn into a color, usually blue, all right? In C++, keywords are always in lowercase, all right? In the program over here, double using namespace, int, and return are all keywords. Programmer defined identifiers, and we'll be getting on these as early as the end of this week, early next week. All right. Program defined identifier words or names are defined by the programmer. They are symbolic names that refer to the variables or program routines. In the program to the right, num1, num2, average, and total are words that the programmer came up with. All right, the person that wrote this program. They're not reserved words. All right, we decided over here, we've got a double, and I'll explain what a double is later. We could decide to call it num1. We got another double. We decide to call num2. We've got a fourth double that we decide to call average. We named these. Right? That's what a program defined identifier is. Operators, right? Operators are just like when you do math problems. All right. Um, you've got, let's see, in this program, um, let's see, we got, it says right here, we've got a plus. I don't see a plus right off, but here's a division, total divided by 2. That's an operator. All right. Plus is an operator. An asterisk is multiplication. That's an operator. Anything that causes an action to inside a program is an operator. So when you think of operators, think plus, minus, divide, equal. Those are operators. Punctuation. We already did this because we already wrote a real quick program. All right. Punctuation is usually a semicolon. Characters, the punctuation characters inside of C++ make up a short list. It's the big part is knowing when to use punctuation. When we start through, here's a program, here's a semicolon. We got carrots that go one way. We've got carrots that go the other way. I mean, arrows that go one way. I call them carrots, but arrows that go one way, arrows that go the other. We got parentheses. Parentheses we'll be using. You need to know how to use them. Sort of a lot like PEMDAS from your algebra days. But it's very important that you learn how to use the punctuation inside of C++ correctly. Syntax. You need to know what syntax is. Syntax is rules that must be followed when constructing a program. Syntax dictates how and when the other 4 elements, the keywords, the program-defined identifiers, operators, and punctuation are used. So syntax is the flow. Syntax is the rules that kind of govern a program. All right, that was a quick tour through the rest of Chapter 1. Um, the big takeaways from this are the 5 parts of a program, the 3 levels of programming, um, the schematic that showed high level language, assembler language, machine language. You need to know the actual levels of those. All right. This is the end of chapter 1, and chapter 1 was just an intro. Now we're going to be getting into some real programming on Wednesday. When you come in, we're going to be putting together some simple programs.